Hello, today we're going to do a little tutorial to explain what pi is, not the pie you eat, not the number pi. And Ben's big sister Jasmine is going to help me today.
Hiya.
So we're going to start off by measuring round some tins to show what pi actually is. I'm going to use inches because they are easier, the numbers are easier to read on my tape measure. So we're going to measure around here. I'll move to you, Jazzy. I'll measure around here. We're going to see on here that that is about 31.8 inches, I'd say. 31.8 inches. That's the circumference of our circle, and we're going to divide that by the diameter of our circle. So I'm going to measure across the top. And this particular circle is 10 inches. So we're going to divide 31.8 by 10, which will equal 3.18. I'm going to do the same with another tin.
Big old tins.
Okay, in my stock pot. Again, this one measures about 27.5. Can you see that on there?
Yeah.
So 27.5 is our circumference. Now we're going to measure across the top. And that one measures about 8.9, I'd say. So I'm going to divide 27.5 divided by 8.9. And that gives us 3.09. And then my last one, got a tin of tomatoes. I'm going to measure around there. That measures about 9.2, I think, probably, or 9.1. What do you reckon, Jazz?
Ooh, let's go with 9.1.
Okay, 9.1. Measuring across the top, across the diameter. That gives us, I reckon, about 2.9. So we're going to divide that by 2.9. We'll see what that equals. So 9.1 divided by 2.9 equals 3.1. Now there's no coincidence that these are all very similar. They're all well, that one's 3.2 if you rounded it, but they're all 3.1 if you round that. Those two are 3.1 if you round them. And that is because basically that is what pi is. It's the circumference divided by the diameter. If I do it on my calculator, if I put pi into my calculator, it's a lovely little symbol, but you could also write it as a decimal. So 3.141592654, and then there aren't enough numbers on my calculator to show the rest of the display because it goes on forever. So it's much nicer to just have that little symbol, which when you're writing it is like that. So pi is round about 3. And what you use pi for is if you have a problem like, in fact I'll use my tin of tomatoes to draw a circle.
Life hack.
I have a circle with a radius. Now a radius is a line which goes from the centre of my circle to the circumference. And if my radius is 20 centimetres, centimetres, I could find out the area of this circle, the area being this bit I'm shading in here, by using a formula. Area equals pi times by my radius squared. So in this particular example, my area will be equal to pi times 20 squared. So that means 20 times 20 times pi. Well, 2 times 2 is 4. That's the easy bit done. So 20 times 2 would give you 40. So 20 times 20 equals 400 pi. So the answer is 400 pi, which is absolutely accurate. However, sometimes in an exam question, they'll ask you to do it as decimal. So if I put 400 pi into my calculator, it'll give me 400 pi as my answer, which
Very,
is
very helpful.
completely accurate. But as a decimal, it would be 1256.6. And because it's in centimetres, and it's because it's area is always squared. Centimetres squared.
So in a non-calculator paper, would they ask you probably to put it in
terms of pi,
'cause you
possibly.
won't have a
Yeah,
calculator.
exactly. They often do that. So the rule of thumb, though, is you could look at that and you could say 400 times by 3, because we know from our early on workings that pi is about 3. So we could do 3 times 400, which gives us 1200. So that's a rough idea that our answer is round about 1200. Or, yeah, 1200. And my boss used to say to me when I worked in Norwich, he used to say, never use a calculator unless you know the answer. And that's kind of what that's about. You've got a rough idea that it's round about 1200
Yeah.
before you even press any buttons on the calculator.
I usually press the wrong one.
Exactly. It stops you making that mistake. Okay, so we've got another tin now. Oh no, another sum. Same tin, another sum.
Life hacks.
Different tin for every sum. So this one we're given a diameter of 64 millimetres. Well, a diameter is basically 2 radiuses, or 2 radii. So this is the centre. So our radius is going to be 32 millimetres.
It's half 64.
It's halves, exactly 64. So to find the area, this shaded part of this circle, I would use the same formula. Area equals pi times 32 squared, which equals 32 times 32 times pi. And since this video is just a little one of 15 minutes, I'm going to do it on the calculator. 32 times 32 times pi is 1024 pi. And if they ask for it as a decimal, you would put it down as 3,216 or 0.99, which probably you would then be asked to round it to 4 significant figures in an exam. So you would round it to 3217, probably.
Don't mix up significant figures with decimal
points.
places.
No, exact decimal places. You're quite
I always
right.
used to do that.
Yeah. So you might get given a question like this one. Oh, I won't draw it. You can see it in the book. Can you see that?
Which one?
This
Number
one here,
10.
number 10, yeah.
Ah,
So we've got a diagram of a square which has got a circle in it. So a circular hole is cut in a square card. Find the area of card that is left. So for that, you'd find the area of your square. Well, we know that this is going to be 60 because we're told it's a square. So to find the area of that, we would do 60 times by 60 equals 6 sixes are 36, and we've still got 2 zeros, so we can add them on. So it's 3,600 millimetres square is the area of our piece of card. And then we're going to find the area of the circle in the middle. Well, the radius is going to be 25 because it's half the diameter. So the area of that circle is going to be pi times 25 squared, which is 25 times 25 times pi, which equals, pi equals 625 pi, which in decimals, I'll just put on the side here, is 1,963.5, and that's millimetres squared. So to find the area of the bit of card that's left once you've removed the circle, you would take this number away from this number. So you have to do, possibly you might want to leave it like that, or you could leave it as a decimal. Whichever way you do it, you'll get the same answer. But you do 3,600 minus 625 pi. And that will give you 1,636.5 millimetres squared is what's left. So with this one, we found out the area of our card, then we found out the area of our circle, remembering to halve the diameter to find out the radius for our formula area equals pi r squared, and then we took the area of our circle away from the area of our triangle, and that square and that gave us the area of the card that's left. And that, I think, is all you need to know about pi.